Hey there, let me hope you're okay, doing well. I'm also well. Our today's topic is Introduction to First Order Differential Equations. So, this being a huge topic, I've decided to introduce, and there are more videos and tutorials you can check on my platform. So, definitions at first point, because we are going to go through the whole course, and if at all there is no base information, it will be just shoddy work. So definitions: differential equation at first point. Basically, this is an equation that involves a dependent variable and its derivatives with respect to an independent variable. So, for example, I've provided here an example of a differential equation. We do say that this one here is a differential equation because it has got derivatives, it has got the variables, that is y and x, and with this y and x we've got also the independent and the dependent variable. So this one is the independent variable, and the other ones on the that deal with the derivatives are the dependent variable. So here again we need to understand what a general solution is. This is a solution of a differential equation that involves one or more arbitrary constants that represent a family of solutions of the differential equation. So if at all you encounter a solution of a differential equation that has got one or more arbitrary constants being represented as C in the solution, then that kind of a solution to a differential equation, we do refer to it as a general solution. And as you can see, I've also provided an example. Consider we are having this differential equation here. So then, if at all we move on to, that is, solve it, we are going to now integrate. That is, when we integrate this, we shall obtain y is equivalent to 2x plus c. This is a kind of a general solution to the equation 1 here, because it has got this constant. So when you encounter such a kind of a solution to a differential equation, it is simply indicates, or you simply just recognize it as a general solution. So apart from the general solution, we've got what is known as particular solution. A particular solution is a solution of differential equation that is now obtained from a general solution by assigning specific values to the arbitrary constants. So with this one, after now, if at all, let me say I do assign this constant a value, let's say 2, then that equation will change automatically. That is, now the solution will change automatically to be a particular solution. So this a particular solution originates from the general solution. Then from there we shall move on again and look on much things. I've talked about classification of differential equation as in my introduction. So when you talk about classification of differential equations, we are having now the differential equation. They are classified according to type, order, and degree, which can also be further explained as linearity. And with these three considerations, they are of great importance when it comes to classifying differential equations. So one, considering type, there is ordinary differential equation. That's type number 1. This kind of differential equation, it involves an equation with ordinary derivatives of a dependent variable with respect to an independent variable. This one I might go back to the previous slide and show you this kind of representation. This one is an ordinary, that is we say an ordinary differential equation because the derivatives are ordinary. That kind we do say it is an ordinary differential equation. Then from there we talk of the partial differential equation. The partial differential equation, it involves an equation with partial derivatives of a dependent variable with respect to independent variables. So this kind of a differential equation, it is different from the ordinary differential equation. The representation of the differential equation is different. That is, the D is not quite the similar one or the ordinary one, or the derivatives are not the ones you know. Of course, I failed to provide an example, but if at all you go and check also, you'll get it. Then considering number 2, the order. You need to understand what the order means when it comes to differential equation. Order of a differential equation is simply the order of the highest derivative in the given differential equation. Example, I've provided this equation. We've got y double prime, 1 single prime, and this 6. So when we try to check now the order of this equation is simply 2, because we are now considering the highest derivative, which is 2. Then considering degree of a differential equation is simply the power of the highest derivative in a differential equation. So when we talk of degree, let's say we had some brackets here around these 2. Of course, the order of this equation is 2. Let's say we had some brackets here, and at the end of the day, place 2 outside the bracket of enclosing this derivative here. So you'll find that now that 2 will be the degree of the equation. That's why we say degree of a differential equation is simply the power of the highest derivative in a differential equation. Actually, I would like to urge you people to join me in the remaining part of the course, because I'm going to take you through the whole course. Be blessed.